Right. Well, how's everybody today? I'm glad to hear that, sir. Okay, fantastic. So we are going to continue this week. In fact, if everything goes according to plan, knock on wood, we should be able to get through everything I want to by Friday. So we're going to continue talking about how to solve trig equations and all the different strategies that go into that. But I want to go ahead and let you know that the homework assignment, that's a packet that you picked up on the way in today. That's going to be due on Thursday. So we are going to go ahead and at the end of the week talk about a few other equations, but they're not covered on the assignment. So we should be able to cover everything through Wednesday in the notes, and you'll be good to go on the assignment. So let me give you something about the assignment very quickly. Okay. If you take a look, the first paper is day 1. The second one is day 2. So on the very back, go ahead and omit numbers 9, 10, 11, and 12 on day 2. Okay, go ahead and omit 9 through 12. Okay, those are going to reference half-angle identity problems, but we are not going to talk about those in here. So we're going to go ahead and get rid of those. So that only gives you 8 questions on the day 2 paper. Okay. Now going into tomorrow, we are going to continue talking about strategies for solving these trig equations, but we're also going to have an exit ticket. So it's got 2 problems. Okay. It's nothing fancy, not factoring, not identities, anything. It's just isolating the trig function and finding me the solutions. Okay. Basically what we've done on this front page of notes right here. Okay. So in fact, if you're looking for some good practice just for tomorrow, just checking your progress, if you do numbers 1 through 6 on the assignment, that very front page, those are going to be very similar to what you could expect tomorrow on the exit ticket. There's just no way we can finish the whole thing this week and still have a quiz, so I'm going to go ahead and do an exit ticket in place of that. Okay, so questions on that? Okay, cool. All right. Well, let's see what we got here. So the goal every time we're trying to solve a trigonometric equation is to isolate the trig function. We've got to get the trig function down equal to some value so that I can go ahead and figure out what angles are going to be my answers. So that's where all students take calculus comes in. Depending on your trig function and whether your ratio is positive or negative, you're going to be drawing triangles in certain quadrants. Okay, so we need to know where they're positive and we need to know where they're negative. Okay. Now, all students take calculus is going to let us know where they're positive, and if you know where they're positive, well, then the remaining quadrants are where they have to be negative. Did we want to do a few of these, or are we okay with these? Take that as a good. Okay, cool. All right. The only other thing, you want to go ahead and pay attention to the interval that you're solving on. If it asks you to solve on the interval from negative infinity to positive infinity, this is looking for all possible solutions. So that means instead of exact answers, you're going to be writing your solutions as expressions. If you're solving for sine, cosine, cosecant, or secant, you're going to take your angle answers and add 2 pi in. Okay. If you're solving an equation that contains tangent or cotangent, then your answer will have plus pi n following that. And of course, you always want to say n belongs to the set of integers. You want to identify your variable. Okay. So any questions about why we do that? Okay, well, cool. So here is the first page of those notes. And I want to say on Friday, we made it all the way down to number 5. And I asked you to go ahead and work through number 6. Okay, so let's go ahead and take a look at this. All right, so number 6, 4 times sine squared of u plus 8 is equal to 11. And we'll talk about the interval in just a second. First thing, all I want to do is get sine of u by itself. Okay, so pretend it was a variable. What would you move first? I'd get rid of the 8, so let's subtract the 8 over. So this would be 4 times sine squared of u is equal to 11 minus 8 will give me 3. Okay, now what? Let's divide by 4. Everything you would have done when you're solving a normal equation. Okay, so that gives me sine squared of u is equal to 3/4. Now I want sine, not sine squared. So how do I get rid of that square? Take a square root. There we go. Okay, now when you take the square root of a fraction, you apply the root to both the numerator and the denominator. So this is going to give me that sine of u is equal to the square root of 3 over square root of 4 is 2. And there's something I'm forgetting, though. Anybody know what I might be talking about? When you're solving an equation and you take an even root, I've got to put, bless you, plus and minus in front of my value. Okay. So there's what I did. You've got to isolate your trig function, so I've got it down. Sine of u is all by itself. It's equal to some value. This is where I turn to the coordinate plane. All students take calculus. Well, you'll notice on this one, it's both positive and negative. So let's kind of break it apart. Where is sine positive? In quadrants 1 and 2. So if it's positive in 1 and 2, where would it be negative? 3 and 4. So with this plus minus, I would go ahead and draw a triangle in each of my 4 quadrants. Okay. So in one revolution, I would be able to get 4 solutions to this equation, right? But remember, this is what I said a moment ago. You want to be mindful about your interval. This only wants me to solve on the interval from pi to 3 pi over 2. So what quadrant are we focusing on? Only quadrant 3. So even though quadrants 1, 2, and 4 would give me a solution, that interval says, it's okay, we don't need those right now. Everybody okay with that? So I'm actually only going to be able to get one solution out of this. And it depends on the equation. You could get 1, 2, 4, or even more. Okay, you can get multiple answers very easily. Okay, so I'm going to go ahead and start to fill in the sides here. Remember, sine has a ratio of y over r. Excuse me. All right. So that means that the hypotenuse is 2. The y value is a negative root 3 because of the quadrant we're in. Anybody think they might know what that other leg is? That's 1. Okay. Okay. Now, specifically negative 1, again, because of our quadrant. But does anybody want me to run through Pythagorean theorem to show that? Okay. Well, do we recognize that triangle? It's a 30, 60, 90. So this angle here, the reference angle, that would have to be 60. Why is that? There you go. Remember, 30, the smallest angle, has to be opposite the shortest side. And 1 is smaller than square root of 3. That's why it's 60. Okay, so I know it's been several days, but we isolated the trig function. We found what quadrant we're going to put my triangle in. Okay, we've identified the triangle, but how does that triangle help me get my answer? I mean, what do I do with it? Oliver? You rotate. You're going to start in standard position, that being the positive x-axis, and you're going to rotate counterclockwise until you hit that hypotenuse. Sorry. Okay. So in this case here, it looks like I rotated 180 plus 60, so 240 degrees. So that is my solution, but remember that I'm asking you to go ahead and write this as a radian. What is 240 degrees as a radian? That's 4 pi over 3, 4/3 pi. Okay. So on this particular interval, there's only one solution that'll make that equation true. Okay. Remember, it's just like any other equation you've come across. We're looking for the angle measures that are going to make it a true statement. Okay. How are we doing? Okay. Cool, 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 cool. Well, let's go ahead and turn that over, and let's look at number 7. Okay, and then you've got these factoring resources that I gave you last week. We are going to go ahead and take a little bit of time today, and I'm going to show you, refresh your memory on some of these factoring strategies as we go into these. Okay, but here's number 7. Yes, sir. Give your back. Okay. All right, now number 7. We've got 4 cosine squared of x minus 1 is equal to 0. Thanks, sir. And we're solving it on the interval from 0 to 2 pi. Okay. Well, this whole page here every one of these equations, we're going to isolate the trig function by factoring. Okay, so you're going to notice this binomial, this is a difference of squares. Okay, we're subtracting two perfect squares. When you factor those, you get groups A minus B and A plus B. Does anybody remember what we call those? Those big words started with a C? Conjugates. There we go. You get conjugates. Okay, so let's go ahead and apply difference of squares to what I have here. So I'm going to get my two groups ready. Okay. So what's the square root of a 4 cosine squared? Okay, 2 cosine. Okay, so do that. And what's the square root of 1? 1. So I've got a plus 1 and I've got a minus 1. Now, if I were to multiply those conjugates back together, it's going to give me the original difference of squares. Okay. All right. So what I'm going to do now is set each one of these equal to 0. Okay. Hopefully you remember the strategy, even though you might not remember the name. We refer to that as the zero product property. Does that sound familiar? Maybe. Okay. But I'm going to take this first group here, 2 cosine of x plus 1. I'm going to set it equal to 0. I'm going to solve that. Hopefully I'm going to get some solutions out of it. Okay. Then I'm going to take the other part, 2 cosine of x minus 1 is equal to 0. I'm going to solve this, hopefully get some solutions out of that. Everybody with me? Now for this first one, if I subtract 1 and divide by 2, looks like cosine of x would equal a negative 1/2. Okay. What would cosine of x equal for the other equation? There we go. Now, the only one on this page is number 7 that's actually kind of unique. If you didn't recognize this equation as a difference of squares, you still could have just isolated the trig function. Let me show you what I mean. Okay. You go ahead and separate these right here. So let's say, first off, I said, okay, I'm going to go ahead and add 1. So 4 cosine squared of x is equal to 1. Well, then I would go ahead and divide through by 4. Cosine squared of x is equal to 1/4. What would I do now? Take the square root. Okay. So that cosine of x is equal to, the square root of 1/4 is 1/2. And remember, what did we talk about when we take an even root? Put the plus minus when you're solving an equation. And you'll notice cosine will equal a positive or a negative 1/2. That is exactly what I got even when I factored it. So number 7 is the only one on this page that's unique. Starting with number 8 down, unfortunately, there's no way to just isolate a trig function and be able to immediately solve. Okay. Remember, nothing like this is going to show up on the exit ticket tomorrow. Tomorrow is just going to be those that you should be able to isolate easily, like the previous page. Okay, well, let's go ahead and take a look at this one. Okay. So let's go ahead and focus on the first one right here. Cosine of x equals a negative 1/2. Okay. Well, where is cosine negative? All students take calculus. All students take calculus. It would be 2 and 3. So because cosine is negative in 2 and 3, that's where I'm going to draw 2 triangles. Because I'm looking to get solutions out of this first equation. Is everybody with me? Cosine has a ratio of x over r. Remember, the radius is always positive. So this is going to be 2. This will be 2. That shared side is a negative 1. In fact, this triangle looks familiar. What's that other leg? It's a root 3. This other one would be a negative root 3. So this is a 30, 60, 90. What are these two reference angles here? 30 or 60? I always forget. They'd have to be 60. Everybody okay? Why? Okay. Well, we've got my 2 triangles. They're filled in. How do these give me my answers? Yeah, let's rotate. So let's see here. If I rotate to the first hypotenuse, I rotated 120 degrees. What is that as a radian? 2 pi over 3. And now I've got to rotate again until I get around to the other hypotenuse. Okay, well, actually, we just saw this one. 180 plus 60, that's 240. So that's 4 pi over 3. So we've successfully solved that equation right there. I was able to get 2 solutions out of it. Okay, but is the problem done? It is? Sure. There's no other part of it I still need to solve. Remember, I still have that other part of the factored version to set equal to 0. Okay. So where is cosine positive? So that'd be 1 and 4. Okay. And it's the same thing. We have an x value of 1, a radius of 2. Okay. It's going to be the exact same triangles that we were just looking at. Okay. This will give me 60. This will give me 60. And now we rotate. So I rotated 60 degrees to that first hypotenuse. So for this one right here, I have another solution, pi over 3, 60 degrees. Standard position again. I'm going to rotate all the way around. 300. But what is that as a radian? 5 pi over 3. So I was able to get 2 solutions out of that equation. I got 2 solutions out of that equation. So in total, I've got 4 answers that'll make that a true statement. And like I said, it depends. Sometimes you might get 1. Sometimes you might get 2 or more. Okay. Depends on what you're given. Okay. How we doing? Okay. All right. Well, let's go ahead and start looking at some other factoring strategies. Number 8. Now, if you're thinking that factoring is the way you're going to go, you want to go ahead and set your equation equal to 0. So let's go ahead and take this product right here. Why don't we subtract it over? So I'm going to go ahead and say cotangent of x minus cotangent of x, interesting, times sine squared of x. Is everybody okay with that? Anybody think they know what kind of factoring I'm going to do here? It's got 3 letters to it. What's the first thing you always look for? Greatest common factor. So this one right here, you're going to factor using a GCF. See, this is a binomial expression. This is one term. This is the second term. What does each term share? Cotangent. So I'm going to factor that cotangent out. So I'm going to say cotangent of x. What's that going to leave me? Oh, it's got to have something minus sine squared. Okay, 1 minus sine squared. Now remember, we were already doing this when simplifying trig expressions. We weren't using them to solve equations, but we were using factoring. Okay, so is everybody okay how I factored that? Okay. Now again, the 0 product property. I'm going to take each part and set it equal to 0. So cotangent of x is equal to 0. Let's solve that one first. Okay. Now remember, on this one, we're only solving it on the interval from pi to 2 pi. Okay. So I'm only going to be interested in quadrants 3 and 4. So we're not going to be looking in quadrants 1 and 2. Everybody's okay? Well, let's go ahead and turn this into a fraction. What's cosine's ratio? It's x over y, right? Does anybody notice a problem? What happens if a side length is 0? It's a quadrantal. Okay, so for these 2 quadrants, there's only 3 possibilities. It has to be pi, 3 pi over 2, or 2 pi. Any of those could be a solution. Okay, so let's check them one at a time. Pi, what was the ordered pair at that location? Negative 1, 0. Okay, so what we need to be able to do is take, because it's cotangent, we need to be able to take the x value divided by the y value, and we're looking to get a 0. Okay, well, let's see. The x value is negative 1, divided by the y value is 0, but what happens when you divide by 0? That's undefined, so pi is not a solution. Okay, well, let's try 3 pi over 2. The ordered pair at that location is a 0, negative 1. So the 0 is x, negative 1 is y. What's 0 divided by negative 1? Oh, 0. And see, that's exactly what we want. So that's a solution. X equals 3 pi over 2. Now, if I take a look at 2 pi, this is at 1, 0. Would x divided by y give me a 0? No. So 2 pi's out. So I only have one solution for that first equation. Is everybody okay with what I've done? Now, the 1 minus sine squared of x, I've got to set it equal to 0. And now I'm going to solve it. So if I subtract the 1, negative sine squared of x equals a negative 1. Okay, you can multiply or divide through, so we'll go ahead and make those both positive. And let's take a square root. So what should sine of x equal? What's the square root of 1? 1. We're forgetting something, though. Remember, we're solving an equation where we took an even root. Plus and minus. All right. Okay, so let's do the same thing. We're going to put this over 1. But sine, what's this ratio again? Y over R. Okay. Again, do we notice anything? Okay, so what do we notice? So your leg is the same length as the hypotenuse. That would force me to make the other leg what? So if there's a leg of 0, this is a quadrantal. So just like the previous cotangent, we can only look at these 3 locations. Okay. So remember, sine is your y variable. Okay. So all I'm looking for at these 3 locations, is there a y that's either positive or negative 1? Let's see, over at pi, what's the y value? 0, so that's not it. Okay, 3 pi over 2, we have a negative 1 right there. Now, the only thing is we'd already gotten that solution on the other one. So that's okay. Sometimes it happens. What about 2 pi? Is it a solution? Nope. That says y is 0. So for this right here, on the interval from pi to 2 pi, I only have the one solution. Only one angle is going to make it work. Okay, how are we doing? Anybody having a hard time? Anybody lost? Okay. Now we're going to go ahead and start skipping around a little bit because I want to go ahead and show you some other different types of equations. But if you were to take a look at numbers 9 and 10, you would solve those using a greatest common factor as well. Yes. Do you have your match? Sure. Okay. So if you are looking for extra problems besides the assignment, I mean, you got some right here. If we have time, we'll go back and look at these, but don't know if we'll have time today. Okay, let's look at number 11. Cosecant squared of theta plus 5 equals 7 minus cosecant of theta. Okay, let's get everything to one side. Okay. So why don't we add the cosecant over? Am I going to be able to combine those? Why not? They're both cosecants. There you go. So they're not like terms. The best I could do is say cosecant squared of theta plus that cosecant of theta. Now, if I subtract the 7, 5 minus 7 will give me minus 2. right. So this is a simple trinomial. Now, the reason we call it a simple trinomial is because the leading coefficient is a 1. Now, remember, you've already done this before. Just think about it in terms of a variable. Somebody give me a variable. Y. So let's say I write this as y squared plus y minus 2 is equal to 0. All I'm doing is replacing cosecant with the variable we chose. Okay? We know how to factor that. Okay? What two numbers will multiply to give me a negative 2, but also add to give me a positive 1? Okay? Negative 2 and what? Well, negative 2 times negative 1 will give me a positive 2. We need a negative 2 and a sum of 1. So we know one of them's got to be negative. 1 minus, 1 plus. Now, the nice thing is 2 is prime, so the only factors are 1 and 2. So it would have to be minus 1 and a positive 2. Is everybody okay with that? Now, see, you've already factored stuff like that before. The only difference now is that instead of that variable, okay, we're using, we're using cosecant. So instead of y minus 1, I'm going to go ahead and say cosecant of theta minus 1. Y plus 2 is cosecant of theta plus 2. There we go. I'll just go ahead and erase all that. There we go. Does anybody want me to multiply those back together real quick to show that it's going to work? Okay. All right, so I got it factored. What do I do now? What have we been doing on the previous problems? How do we isolate? We got to take each group and do something with it. Only after I set it equal to 0. Okay, so now I've got to take this first group. So if cosecant of theta minus 1 equals 0. Now I can go ahead and add 1. So cosecant of theta is equal to 1. And don't forget, we still have to solve the other part as well. Cosecant of theta plus 2 is equal to 0. So cosecant of theta will equal negative 2. Okay. And now I'm going to take a look at each one of these. I got a trig function equal to a value. I'm ready to get some answers. Okay. Is everybody okay? Okay. Well, let's take a look at this first one. So cosecant of theta equals 1. Remember, cosecant's ratio is r over y. Oh, we've seen this before. What's about to happen? Okay. What happens if a leg is the same length as the hypotenuse? You have a length of 0. That means it's a quadrantal. Okay. So I'm looking at my interval here. This wants solutions between 3 pi over 2 and 2 pi. So 3 pi over 2 and 2 pi. So those are my only possible locations where I can get an answer. Okay. Now, what I'm needing is this positive 1 right here. Okay. Let's take a look at 3 pi over 2. The ordered pair is a 0, negative 1. So I should be able to take the radius divided by the y value at that location. Hopefully, I'm going to get a positive 1. Well, let's see. The radius is 1. What's the y value, though? Negative 1. So see, that gives me negative 1, not the positive 1 that I want. So 3 pi over 2 is not an answer. Okay. Well, 2 pi work? Well, let's see. R over y. So the radius is 1. What's the y value? Okay, 0. So that one becomes undefined. So unfortunately, this cosecant equal to 1, I'm not able to get a solution out of it on the interval they want. Sometimes it's going to happen. Okay. Does that mean there's no solutions at all? What am I forgetting? Yeah, don't we have that other one? Cosecant equals negative 2. Okay, we still got to go through that. Okay, all students take calculus. Where is cosecant negative? Remember, what's the reciprocal of cosecant? So if it helps you to do it in terms of sine, that'd be okay. But what two quadrants am I going to be drawing my triangles in? 3 and 4. That's where cosecant is negative. Okay. But are we forgetting something? Yeah, remember, it only wants 4. So even though there would be a solution here, we're not going to worry about it. Okay, you always want to pay attention to the interval it's asking you to. Okay, so this is over 1. So it's still r over y. So I've got a hypotenuse of 2. This is negative 1. What's that leg? Root 3. Okay. What type of triangle is this? 30, 60, 90. This one would have to be 30 because it's opposite the shortest leg. Is everybody okay? How do I get my solution? There we go. Soren's right. Start here. Rotate all the way around. So here I rotated 330 degrees. So what is 330 degrees in a radian? Pi over 6. So on that interval, number, what are we on here? 9? Okay. Or no, this is 11. Yeah, we skipped a few. Has 11 pi over 6. How are we doing? Is there anybody lost? Okay. Now, let's take a look at the next one. So this is where I'm going to go ahead and show you a strategy that you've probably not seen before, and that's okay. Now, this one is already set up. 2 sine squared of alpha plus 3 sine of alpha minus 2 equals 0. This is a general trinomial. Okay. If your coefficient, your x squared coefficient, is anything besides 1, we call it a general. Okay. So we used y last time. Give me a variable. X. So let's say I just replace sine with x. So 2 sine squared becomes 2x squared. Plus 3 sine becomes 3x minus 2 equals 0. We've factored stuff like that before. Okay. But if it's general, there's a method that I like to use. I mentioned it on Friday, and it was on your factoring map. Okay. It's this right here. My father drives a red Mercedes convertible. The first letter of each step is a step. The first letter of each word is a step in the process that tells you exactly what to do. Now, here's the thing about this. I'm going to say it at the very beginning. If you love this method, fantastic. If you hate this method, fantastic. It does not matter to me. Here's what does matter to me. If you don't like this method, you've still got to be able to factor trinomials. So whether you go back to good old guess and check, box method, grouping, whatever, you got to be able to break them apart. Okay, so let me show you this. Let's say I wanted to factor 2x squared plus 5x minus 3. Okay, well, the M stands for multiply. You're going to multiply the leading coefficient times your constant. That's a negative 6. Father. Now you're going to factor. This is very similar to the guess and check portion. What two numbers will multiply to give me negative 6, but add to give me positive 5? It would have to be negative 1 and 6. This is the most important step in the entire process. If you can find those two numbers, the rest of this is going to go super fast. Okay? So my father, multiply factor, drives. So we're going to divide. You always divide by that leading coefficient. Okay. A red. R stands for reduce. So we're going to simplify these fractions. Negative 1/2. Now this will happen occasionally. 6 divided by 2 is 3. If it divides evenly, leave it over 1. You need a fractional value to create your binomials. Okay. So my father drives a red, multiply factor, divide, reduce, Mercedes. We're going to move these numbers. At this point, you put the variable in each denominator and you read it from the bottom up. So this is going to be negative 1 over 2x. That's a 2x minus 1. 3 over x. That's an x plus 3. There you go. In fact, if you've had Mr. Heinrich before, this is similar to his, I think he calls it slip and slide method. Okay. All right. Has anybody ever seen that before? You've seen this before? Fantastic. Okay. All right, so let's run through this next one and watch how much faster it's going to be. 3x squared minus 7x minus 20. Okay. What's 3 times negative 20? Negative 60. So I'm looking for a negative and a positive. Okay. Whatever two numbers I choose has to add to give me negative 7. And there are two. See, that's why this is the most important step. Negative 12, positive 5. Okay. What am I going to divide them by? Always divide by the leading coefficient. Now we're going to simplify. 5/3. Now negative 12 divided by 3 is a negative 4. But remember, if it divides evenly, put it over 1. Once you've got your reduced fractions, put the variable in the denominator and read it from the bottom up. So this is x minus 4 times 3x plus 5. See how that went a lot faster? Okay. Well, now let's go back over here to this problem. Okay. So let's factor it. 2 times negative 2. Negative 4. But two factors that'll add to 3. Negative 1 and 4. What am I going to divide them by? 2. So that's a negative 1/2. That would be a 2 over 1. I'm going to put the variable in each and read it from the bottom up. So what are my two groups? 2x minus 1 and x plus 2. Now, the only thing is we're not working with x. What are we working with? Sine. Okay. So I'm going to take this factored version and I'm just going to rewrite it. So 2x minus 1, that's 2 sine of alpha minus 1 times x plus 2 sine of alpha. That is horrible looking. Sine of alpha and then plus 2. And if anybody would like, I can go ahead and multiply those back together, show you that we get the original trinomial. Okay, would anybody like me to do that? Okay, now that I've got it factored, what do I do? Split them up, set them equal to 0. Yeah, it's the same process over and over again. So if 2 sine of alpha minus 1 is equal to 0, sine of alpha would equal 1/2. Okay. All right. Now let's solve this one before we even look at the other one. Okay. Sophia, where is sine positive? All students take calculus. 1 and 2. So I'm going to go ahead and draw triangles in 1 and 2. And quick check. Am I even going to be using both of these or can I get rid of one? Okay. It wants it on 0 to 2 pi. So we're getting a solution out of each one of those. Okay. Let's see. This is y over r. So we've got 2, 2, 1, 1. We've seen this triangle a lot today. That would be square root of 3. What are my reference angles? Are they 30 or 60? They would have to be 30. Okay. Once you've got your triangles, you simply rotate. So I'm rotating to the first hypotenuse. That's 30 degrees. So alpha would be pi over 6. That's 30 degrees. Now I'm going to rotate to the second hypotenuse. That's 150. What is that as a radian? 5 pi over 6. So that first part right there, I've already got two solutions. Now the problem is done, right? No, what am I forgetting? Yeah, don't forget about the second part. So sine of alpha plus 2 is equal to 0. So sine of alpha equals negative 2. Well, that is a y over r. Is there a problem here? What? So this one's going to be a quadrantal, right? No. What's going to happen here? No solution. No solution. Why? If the leg is ever longer than the hypotenuse, don't even bother. There's no answer you're getting out of that. Okay. Now, if you actually know a leg is 0, or if a leg has the same length as the hypotenuse, then it's a quadrantal. So this one only gave me 2 solutions. Okay. All right. So I'm going to show you one last thing, and then we'll be done. I'm sad too. Okay. Now, if you take a look at number 13, there's another trinomial that you'd go ahead and solve. Okay, it's another good problem to take a look at. But I want to take a look at number 14 because this has 4 terms. Okay, in order to factor a 4-term expression, you're going to use what's called grouping. Does that sound familiar? Okay, so I've got an example here that I pulled off that sheet I gave you. I'm going to go ahead and remind you how to factor by grouping, and then I want you to try number 14 for tomorrow. Please try the problem. Okay, I'm noticing a lot of people are not practicing these problems. They're not doing the homework, and then they're coming into tutoring. How can I get my grade up? Or can you explain an entire lesson in 5 minutes? It's not possible, folks. You got to practice. Okay, please take a few minutes to try it. Okay, so let's say I've got x cubed minus 2x squared plus 6x minus 12. There's no GCF to all 4. Okay, so that's where we go to grouping. So what this means is I'm going to take the first 2 terms and I'm going to put them in parentheses or group them. Okay, then I'm going to take the last 2 and I'm going to put them in parentheses. Okay, here's the thing: the 2 groups you create, they always have to be added together. Okay, so why do you think I'm doing this? What am I trying to find out of each smaller group? A GCF. What divides x cubed and 2x squared? X squared. So if I factor out an x squared, that's going to leave me x minus 2. Plus, what about a 6x minus 12? I can pull out a 6. That'll leave me x minus 2. Now, what you've got here is what we refer to as a greatest common binomial factor. Up until now, you've pulled out just a common factor, whether it's a single term or a product. Here, you're pulling out an entire group. And you're going to know you're on the right track because these 2 should be identical to each other. Okay, so if I factor that group out, I'm going to go ahead and put x minus 2. What do you think I'm going to multiply that by? There you go. The GCFs that you pull out, you're going to combine into their own group. And see, now I can still use the 0 product property. Now, number 14 has tangent. Does that change anything? Oh, exactly what you did here is what you're going to do with number 14. I'll go ahead and tell you, you should be getting 3 answers. I'll even show you what those answers are. Okay. You should be getting pi over 3, 2 pi over 3, and 3 pi over 4. Okay, please try this problem. Now remember, you also have an exit ticket for a grade tomorrow. It's going to be 2 equations, not like this. You should be able to easily isolate the variable, or the trig function, I should say. Okay. All right. How are we doing? Cool. All right. Oh, why did I erase that? There we go. I want to erase this part, not that top. X cubed, 2x. Oh, actually, I can't erase that. Okay. Okay.